In this section, we are looking at rational functions. Now, a rational function is a function of the form p of x over q of x, where these are both polynomials. So essentially, it's a polynomial over another polynomial. So it's fractions that we're dealing with polynomials. So we will be doing a complete graph analysis for these functions. We're analyzing the graphs. Essentially, this is getting ready for calculus. So if you take calculus, they ask a bunch of other things about the graph. So these are doing all the non-calculus things about a graph before you get to calculus, where you'll do these things plus some calculus things. So this is basically getting you ready for that. And the first analysis that we're looking at are the intercepts. So the X-intercept, this is where the graph crosses the x-axis. Now the y value of every x-intercept is 0. So my process in order to find the x-intercept is to set the numerator equal to 0. I don't set the denominator equal to 0 because the denominator being equal to 0 is undefined, and that's actually going to be something else. So you only need to set the numerator equal to 0. Now in a similar way, the y-intercept, this is where it crosses the y-axis, the x value of every y-intercept is 0. Therefore, to find the y-intercept, we want to set x equal to 0. So if we look at number 1, it says find the x and y-intercepts of the rational function algebraically. I kind of want to take this out of functional notation. So I'm just going to call this y instead of r of x. And then to get the x-intercept, I want to set the numerator equal to 0. So this will be x squared minus 9 is equal to 0. And then I want to solve. So if I factor this, you could use the square root property if you wanted to. I'm going to factor, and then x will be equal to negative 3, x is equal to positive 3. So as points, these are negative 3, 0, and 3, 0. For the y-intercept, I want to set x equal to 0. So y is going to be equal to 0 squared minus 9 over 0 squared. And you'll see we have a big problem here because we have, well, this is going to be negative 9, but this is going to be 0 on the denominator. And I can't have that. So y is undefined. And what that actually means is that, so there's no y-intercept. So that is possible. So again, our x-intercepts are negative 3 and 3, and we do not have a y-intercept on this problem.